Welcome everyone. My name is Martin Plattner and I recently graduated with a Master in Computer Science from the University of Innsbruck. In this talk, I want to give you an overview of my Master Thesis, Generalizing BlockSci to Cross-Chain Analysis of Forked Ledgers. Let me start by breaking down the title word by word. A ledger in the context of my work is a blockchain, such as Bitcoin. These blockchain systems have gained popularity within the last years. As a result, we also see an increased demand to analyze the data within those systems, for example, from law enforcement agencies. What's usually done is a so-called single chain analysis, meaning that one chain is analyzed at a time. A challenge regarding blockchain analysis are the large amounts of data. For example, the popular Bitcoin blockchain contains hundreds of gigabytes of financial transactions. General-purpose databases are not optimized for blockchain data and provide insufficient performance. Instead, what we need are specialized tools like BlockSci. BlockSci is a highly optimized blockchain analysis tool developed at Princeton University. BlockSci has a parser that converts the raw blockchain data into an optimized format. This optimized format is loaded into a custom in-memory database for analysis. The analyst can then access all data using a convenient and flexible Python API. BlockSci's highly optimized architecture allows to iterate the entire Bitcoin blockchain in only a few seconds. In my thesis, I was especially interested in the analysis of forked ledgers. A fork describes the split of a blockchain into two branches. This commonly occurs when the users of the system disagree on the rules of the ledger. For example, a popular fork is Bitcoin Cash, which split off Bitcoin in August 2017 after disagreement on the maximum size of a block. Forked ledgers share a common history with their parent chain. In other words, all blocks prior to the fork are identical on Bitcoin and Bitcoin Cash. This has important consequences. Users that owned coins prior to the fork can spend them in both the main chain and the forked chain. By spending the coins on both chains, users inadvertently create direct links between their digital identities across chains. Those links provide a powerful data source to analyze users and their behavior across chains. However, to do that, a single chain analysis is not enough. Instead, we need what we call a cross-chain analysis, meaning that we have to combine the data of multiple chains and analyze them together. BlockSci does not efficiently support such cross-chain analysis out of the box. So my task was to add a new multi-chain mode to BlockSci that allows to efficiently analyze forked ledgers together. I started by gathering a list of requirements. Let me briefly cover some of them. A major goal was to provide the user with normalized addresses. An address in a blockchain system is similar to a bank account in the traditional banking system. We wanted to deduplicate addresses across chains such that the analyst can study the usage and the activity of the same addresses across chains. Further, we wanted to support Bitcoin and Bitcoin Cash. We also wanted to optimize the memory consumption by only loading the identical pre-fork blocks into memory once, and also maintain the high performance of BlockSci. To fulfill these requirements, several changes were required. I added a new JSON-based config file that supports links between chains. I added a multi-chain mode to the parser that can parse multiple chains together and deduplicate addresses across chains. I changed the data layout such that it can efficiently hold data of multiple chains. And finally, I updated the analysis library to handle the new layout and share identical blocks across chains in memory. These changes represent the main part of my thesis and required a significant amount of time and effort. However, in this talk, I will not go into detail on these changes due to a lack of time. Instead, I think it is more interesting for you to hear what can be done with the extended BlockSci version. I used the new multi-chain mode to implement a novel analysis technique, cross-chain address clustering. Let me first cover the established single-chain variant. In a blockchain system, every user can create an arbitrary number of addresses that appear to be unrelated to the analyst. This is a problem for analyses that want to study data on a per-user level. To overcome this issue, the analyst can use the established address clustering technique. It tries to cluster addresses that belong to one user by applying heuristics on the existing transaction data. The result is a graph of addresses where addresses that likely belong to one user are linked. On the left, you can see an example of a single-chain clustering for Bitcoin. It indicates that address 1 and address 2 belong to one user, and address 3 and address 4 belong to another user. The same single-chain technique can be applied on Bitcoin Cash, where we might find that another result due to the fact that the same coins can be spent differently on Bitcoin Cash. Using Bitcoin Cash data, we might find that address 2 and address 3 belong to one user. Now we can make the step from single-chain to cross-chain clustering. Recall that addresses are normalized across chains in the new multi-chain mode. This allows us to combine both single-chain clusterings and create an improved cross-chain clustering. By doing that in our example, we learned that all 4 addresses likely belong to one user. This finding would not have been possible by only looking at both chains individually using single-chain clustering. In my work, I used Bitcoin Cash to improve for Bitcoin clustering and could identify over 1 million additional edges. This affected roughly 100,000 users with about 30 million addresses. We were the first to implement cross-chain address clustering for large blockchains like Bitcoin and Bitcoin Cash. Together with the founders and developers of BlockSci and other researchers, I could recently publish my work in a paper at the Usenix Security Symposium 2020. Let's conclude this talk. We started with the assumption that forks offer a powerful data source due to the shared history and the resulting links between chains. Therefore, we implemented a multi-chain mode to BlockSci that allows cross-chain analysis of forked ledgers. We used this new multi-chain mode to implement cross-chain address clustering and found that the privacy of users can be heard across chains. If you want to learn more about my work, please visit my website where you can find the full thesis, the code, and the paper. Thank you.